Hi class, in this lesson we're going to talk about polynomials and a few properties about them. First of all, descending powers and leading coefficients, and then later we're going to talk about combining like terms and what like terms are. So first thing is our descending powers. Now the powers are the exponents, and so each one of these has an exponent. This y actually has a 1, then this one has a 3, a 5, a 4, and then this 12 actually has a y to a power. It's got a y to the power of 0. Because we learned in the last lesson that anything to the 0 power is really 1, so this is really 12 times 1, because the y to the 0 power is 1. So what we're going to do is rearrange these so that they're in descending power, starting with the highest exponent first, which is the 8y to the 5th. So we rewrite it to be 8y to the 5th, and then minus 9y to the 4th, and the next lowest power is the negative 6y to the 3rd, so it's negative 6y to the 3rd. And then the next one we have is there's no second power, so we jump over to the y, so it's plus y, and finally plus the 12. Now we don't have to rewrite the 12 and then y to the 0, you just put the 12 there. So this is descending powers for this first example. Let's take a look at the second one here. We've got m to the 3rd, 2nd, 1st, and then of course y to the 0 or m to the 0 on that one. So it's exactly backwards, so we just need to rearrange it to be negative m to the 3rd plus 6m squared plus m minus 2. Okay, so that's descending powers. That's the first topic up here. And then the second thing is leading coefficient. Now, what a coefficient is, first of all, is the number in front of a variable. So if I was to draw off to the side, if I had 5xy, the coefficient there is the 5. It's the number in front of the variables. So for us, the leading coefficient, and leading means the one out in front. Now, this only happens when you have it in descending order, so the leading coefficient for the first problem is the 8, and the leading coefficient for the second problem is there's a negative 1 there. It just has a negative sign, but there's actually a negative 1. Okay? So leading coefficient for the first term was 8, the second one was negative 1. Now, if you tried to do it at the beginning of the problem, you would have seen that we had a 1 right here for the y, and then a negative 2 was the first thing on the way it was originally written, but those aren't the correct answers because they're not in descending order yet, descending powers. Okay, so they have to be in descending order first, and then you get to talk about the leading coefficient. So now we're going to take a look at combining like terms. The first thing we need to understand is what like terms are. Like terms have the same amount of a variable. Same amount of a variable. Now the reason why I say it's not just the same variable, it's the same amount of the same variable, is because notice in this first problem they all have y's to the 3rd. Okay? Now because they're all y to the 3rd, that's the same amount of y. If there was like an extra y squared over here, that is not a like term, so it wouldn't be added with these other ones. So let's actually add these up. Now, what I like to do is I like to usually circle or put a square around like terms, or I just do triangles around these ones. But there aren't any not like terms in this first problem, so we're going to combine them. So basically what's happening is it's saying I've got negative 5y to the 3rd, I've got positive 8y to the 3rd, I've got negative y to the 3rd. How many y's to the 3rd do I have? So I just take my negative 5, I add my 8, and I subtract my 1 that was in front of that other one there, the last one. It's really a negative 1 there. So I just add this up, and negative 5 plus 8, it would be 3, minus 1 is really just 2 y's to the 3rd. Okay. Now I usually don't write it like this, but I'm doing that in my brain, in my head mathematically, when I'm working out the problem. Okay. So now the second problem, it has to be rearranged so that I can see it better. I'll put squares around the 6 or the x. Okay. So there's two different x's that need to be added together. and then I'll put a triangle around the y's. Okay, so you can see the like terms are the red squares and then the green triangles. So I want to add my 6x and my negative 9x, and that gives me 6x minus 9, which gives me negative 3x. And then I want to add my y's, so I get 5y plus 2y, and that's positive 7y. And that's as far as I can go because the x and y are not like terms, so I have added the ones that have the same amount of each variable, and they both had, when I say same amount, again, I'm talking about the power, the exponent. Okay. So let's combine like terms on a larger problem. So now again, I'm focusing on which variables have the same amount, or same amount of each variable. So when I look at 6x squared y, I look at this one, and that does not have an x squared, so this is not like terms. The second one has x squared y again. This is a like term with the first one, and the last one is not. So let's put a triangle around these. They are like terms. And then let's look at the other ones. I've got negative xy squared, or sorry, negative 6xy squared, and this one is xy squared. Those are like terms, so I'll circle them, and then I'll combine them. So I look at the 5x squared y and the 9x squared y. How many x squared y's do I have? Well, I had 5 plus 9, which is 14. So there's 14x squared y. Now I look at the circles, which is the negative 6 and the 13, and I go ahead and combine those to be negative 6 plus 13 is going to give me positive 7 xy squared. And that's as far as I can go with this particular problem because there's no more like terms that I can deal with.